Hello and welcome to the program. I'm Carl Pauls. I'm here with Gabe Ignetti, Chris Bergen, and our special guest, Doug Plata. Doug Plata is an urgent care physician, the president and founder of the Space Development Network. He speaks frequently at space conferences, radio, and podcasts. His primary interest is in the near-term development of humanity's first permanent foothold off Earth, starting with the moon and the steps necessary to achieve full self-sufficiency on a small scale. Welcome to the program, Doug.
Thank you, Carl. Actually, let me just add something to that introduction, and that is the Space Development Network is a network free to join for space advocates. We gather together in Zoom meetings, organizing people according to their interests. So, for example, we have an agriculture working group that has developed a pretty sophisticated plan for initial agriculture for like initial permanent crew, and other working groups as well. So colonizing the moon is what I was asked to go ahead and present about. And let me go ahead and just start with an overview. So I'm going to sort of leave up this index here on the side so that we can see the steps, the different phases. And I'm breaking it into these yellow parts, which are the phases. I believe that this is the most likely way that things are going to develop, especially in view of the development of the Starship fleet. I think it's going to drive a lot of these things, but there's going to be a logical order that is probably going to happen. But what I'm doing is I'm adding in these green items. These are sort of technologies that come along the way or are employed at different phases. And so to give you the full picture about how we will colonize the moon, I'm sort of developed this outline because it's part of the picture and because I was asked about it. I call it phase 0 because I don't think the Artemis program is going to have much to do with the establishment of a base or settlement on the moon. But I just want to go ahead and add it because it is where we're at now, and it is probably where we're going to have happen before 2030. So the Artemis program, as I'm sure you all know, is sort of based around it's a government program based around the SLS. The Orion capsule gateway, and then with SpaceX's HLS, the lander. And the plan is to go ahead and have the first woman and the first person of color land on the moon. And it's very government-centric. It's really a plan that was started to be developed more than a decade ago. And I believe personally that it is being overcome by events, in particular SpaceX with their development of Starship, and not just the Starship, but the Starship factory producing a Starship fleet, is going to so dramatically reduce the prices. And I think from a capability standpoint, in terms of being able to do everything that the Artemis program is planning on doing plus more, I think reality is going to force the decision makers to transition. And the big thing is you just look at the cost comparison, and there is no comparison. Estimate of $4.1 billion, maybe 20 tons to the lunar surface, 4 people, 4 astronauts picking up rocks to add to the Apollo samples. Compare that to a end-to-end Starship system where you could even launch safely on a Dragon capsule and dock it with a refueled HLS in orbit. And there's ways to be able to do the entire Artemis mission at far less cost.
What's an HLS?
I'm sorry, Human Landing System. This is okay. NASA has paid SpaceX and Blue Origin to have a lander, which I definitely support. But frankly, if they are just put out a request for information, is there a more cost-effective way of achieving the same goals as Artemis? I think it wouldn't be very difficult to come up with an alternative. So I think that the government program is, we might have 1 or 2 missions, crewed missions, but probably not beyond that, is my view. Now, I want to mention in terms of even before the initial permanent crew lands on the moon, really getting towards establishing a permanent foothold off Earth, I do think that there does need to be some infrastructure in place, in particular a power system. Now, this is our concept for the solar drapes. These would be about 60 meters tall, telescoping poles, a way of deploying, sort of digging holes and deploying them. This would be sort of a maximum power for the minimum amount of sort of support structure, minimum amount of mass. We have produced a poster presented for an organization called LSIC, and we estimate, after taking into account all of the inefficiencies, self-shading and peak of eternal light, the percent of the lunar year that gets sunlight, and support structures and efficiency losses, it'd be 5.1 megawatts could be provided at a specific peak of eternal light at the south pole of the moon with a single 100-ton Starship payload. And so we're talking industrial scales of power could become available right at the beginning if we so chose to do something like this. Now, I know you guys are real thumbs up on fission power, as am I, most definitely. But I think that there is value to using solar power at those peaks of eternal light initially. But then as we begin to develop and expand towards the equator, we absolutely have to have fission power, I believe. And so that definitely plays a role. Okay, so now, really what I think is the first phase is what we are proposing in the Space Development Network, and that's what we call StarHab. StarHab is simply a Starship, particularly the lunar version, that's landed and then using tethers, maybe an airbag, to tilt over and to drop down to horizontalize a Starship. It would be like just the most simple way to be able to get 2.5 times the volume of the International Space Station in a single landing and tip over, horizontalization. We get this picture on the right-hand side actually from a paper that was done, I think it was by some International Space University students who did a really good paper on it. We're taking it a step further in the Space Development Network. We're looking into a great deal of detail in terms of the 3 floors of the StarHab, laying out the designs, and we have created 3D printed files for a 30-inch version of it so that we can physically show people and send copies to like space YouTubers. Here's a picture. So at the last annual National Space Society conference, we presented our 3D model, and we're in conversation with both the NSS and the Mars Society to see if we can move towards the construction of a full-scale analog base with hopefully a donated Starship prototype, and then being able to weld in the 3 floors and actually have a facility that multiple organizations can use to conduct simulations of what it would be like to have a StarHab. Let me just mention, because it's probably would be a question that you guys would have about the shielding. The simplest sort of shielding is just to use the regolith. And if you get a minimum of like 11 centimeters thick of regolith, telerobotically use different ways of doing it. But for example, sort of a mining conveyor belt that you get loose regolith and just bring it up the conveyor belt and drop it in a sort of contained area around the StarHab. If you have a minimum of 11 centimeters thick of regolith, which is not a lot, that'll protect you from solar particle events and buys you time to maintain those robots to continually add more and more regolith to where, honestly, you would have more time than time is passing away in terms of how long you can stay. So start with 11 centimeters, and then as you keep on adding, you'll be eventually able to reduce the GCR, the galactic cosmic ray radiation, down to what you could go an entire career limit of about 1,000 millisieverts. Chris, you have your hand up?
Yeah, 2 quick clarifications. The regolith is just a loose, dry, sandy stuff on the surface, correct?
Yeah, thank you. I need to define my terms.
But you said you tip it over, so when it comes down and lands, it probably land vertically.
Yes.
Built everything on the interior sideways. So when it falls over, things are right side up. That's what you're talking about.
Well, no, to get into some of the detail, basically imagine if this was constructed so that on Earth, so that in the payload bay you have the walls, and we have, I can get into the technical details about how we enter into the methane tank, into the LOX tank, and yet have sealable doors. And this is 1,000 cubic meters. This is the volume of the International Space Station. But what you do is you have in there, to be able to fit through the doors, you have sections of floors, you have walls, and then you have equipment and furniture and things like that. And there would be a period of time in which the crew would land separate from the StarHab, and then they'd enter in through the airlock. They'd go into the payload bay, and then cut into the doors into the methane tank, the forward and the aft section of it, and then start moving the hardware through and start installing it on pre-welded mounts in the methane tank and LOX tank. And you'd have to cut down comer and stuff like that.
So the interior is one big IKEA, basically.
Yes, there'll be a lot of flat pack furniture. You bet.
Okay.
Absolutely. And man, I'm totally looking forward if we could get this StarHab analog base, preferably at Kennedy Space Center, but secondarily at Boca Chica, and to go through that process of how would these analog crew go through and actually, assemble the entire StarHab, all three tank sections. That would be just a lot of fun and I think very practical and useful. Okay, so I mentioned this shielding. Food, we have identified different sections of the StarHab to be able to grow food, and it would be probably strictly hydroponic, albeit if you crush rocks and add organics, you can, you don't have to deal with the gritty regolith, the lunar dirt, but you can make your own soil that's safe, or you just go straight hydroponics. And most food plants you can grow hydroponically. Trees are a different matter, so we stick with things like strawberries for fruit. But our agriculture working group has this plan that we developed. Okay, now, this is not a phase, but this is so important to understanding our future on both the moon and Mars. I just really want to focus on this and emphasize this, and that is the Starship fleet. So as you all may be aware, SpaceX down in Boca Chica, Texas, is systematically developing Starship. It's a 2-stage. It's really designed for Mars, but it will work perfectly well for the moon. They just did their 4th launch, the integrated flight test number 4, and it was really very successful, not complete success, but a high degree of success, to where the first stage actually boosted back, came down, actually hovered over the water in the Gulf, just off where they launched, and actually settled in. And it's so successful that they're actually thinking about, on the next flight, bringing it back to the landing site and actually having the launch tower catch it in midair and preserve all of those 33 engines and all of the savings that goes along with that. Meanwhile, in the last flight, they had the upper stage actually enter into the atmosphere. It wasn't completely successful, but it was successful to the extent that it came down and also seemed to hover over the water before dropping in. And so hopefully in another couple of flight tests, they'll actually be able to do the same thing, go ahead and attempt a landing back at the launch site. So Starship is, in terms of capability, it'll be about equal to the Saturn V in terms of payload to low Earth orbit. But with refueling in orbit, it'll be able to send the entire 100 to 200 tons on translunar injection or to the moon or TMI to Mars. And that will be just a complete revolution. But it doesn't stop with just the Starship itself. They are cranking out probably now about 1.5 engines per day. And I personally believe that the docking is not going to be a problem, and the storage of propellant with like zero boil off, I think that that's going to be pretty straightforward. As I spoke with a leading researcher on this topic, we both think that. They are now completing the construction of the Starship factory, which will be able to use these engines to crank out every week a brand new Starship. And so Elon's goal is to go ahead and establish a fleet of about 1,000, perhaps, 2030 or maybe 2031 or 2032. But we're talking a Starship fleet that would able to send, 100 people at a time or 100 tons at a time. We are really talking about, we need to scrap all ideas we had about, a few government astronauts in a permanent base on the moon, 4 astronauts. Just need to scrap that and really open up our ideas in terms of what can be done in terms of establishing humanity's permanent foothold on both the moon and Mars. As I look at the engine production rate and the Starship factory, I believe that we are in the tipping point of a historic revolution where it's the point in which humanity begins to spread beyond Earth. That is at least as significant as like Christopher Columbus discovering the New World. I can't emphasize how historically significant this is. And I predict we're going to be seeing this within the next 10 years. So,
wow.
Yeah. it's a reality, and I'm excited to be alive at this time. Now, let me just mention at this point, Moon versus Mars. I'm a Moon first advocate, but frankly, I think Mars is going to be developed, like between 2 and 6 years after the Moon. However, the Moon does have some pretty significant advantages over Mars that I don't think should be ignored. And that is the travel time to the Moon could be like 3 days there, 3 days back, maybe 2 days at the Moon to unload, and then 3 days back on Earth to maybe do a quick inspection, to load propellant and load people. So it comes to 11 days for a round trip for a single starship out of a starship fleet. Whereas going to Mars, you have to wait until the next Earth-Mars window opens, and that's every 26 months. So when you take 26 months, you divide it by, let's say, 11 days. The difference is about 72-fold, with the Moon having the advantage. So it could be that we'll have crew landing, on Mars maybe just shortly after the Moon. But in terms of the rate at which a base and a settlement can be built up, the Moon has an extreme advantage. 7.2 is not a small number. It's a huge number. And so I predict that, yes, we are going to be settling Mars relatively soon, but the Moon is just going to take off in terms of a very large international lunar base. And then that's going to transition, I believe, into private settlements. Okay. Now, the dollar sign, the relevance here is that you could probably pack 200 people in a ship going to the Moon because it's only a 3-day ride. But to Mars, it's going to be difficult to pack 100 people in. And so you can divide the cost by 200 instead of 100. So the ticket price is going to be significantly less going to the Moon than going to Mars. When you look at the wealth curve, that's significant. Some people will only be able to afford to go to the Moon, and they cannot afford to go to Mars. And so I think that is something that also favors the Moon, is the significantly reduced price. Now, the other thing that nobody else seems to talk about, but I don't think we can ignore, and that is when I go to space conferences, it's about 85% are male, and many of us are married, and yet our spouses don't come with us. So there's a strong bias towards males that are interested in this sort of thing. What do older people who've lived long enough to save up money, what do grandmothers, what do they like to do? They like to stay in touch with family, stay in touch with friends, okay? You can do that from lunar distances with a remote presence. You can attend a grandchild's graduation or marriage or Thanksgiving dinners or whatever, okay? And I think that this may be the decision maker for a certain percentage of the people as to whether they would choose to go to the Moon or Mars, because they just don't want to cut those family ties and cut the ties with their friends by going to Mars, where on average it's about 14 minutes time delay. So you can't really be telepresent. You can only send video emails. And so again, I think the Moon has a distinct advantage, but especially because of the proximity of the Moon. There's more that could be said about that. I mean, Mars does have more accessible resources, so that is definitely an advantage, but I don't think it overcomes the strength of all of these advantages of the Moon. Water ice in the poles, the Moon is not tilted, and so the poles, the north and south pole of the Moon, have permanently shadowed craters. And we now have proof since 2009, a mission called L-Cross proved that one of these craters that was tested is water ice, and there's organics in there in a substantial amount, and the organics includes several different carbon chemicals and also a significant amount of ammonia. So you got nitrogen is there as well. And if a lunar base could recycle their carbon and nitrogen, they would need only small inputs to be able to maintain their greenhouses and whatnot. And so we have come up with this idea of an ice harvester that combines several functions into a single piece of equipment, to where the icy regolith, the dirt, is dumped into the ice harvester. And instead of transporting the ice to somewhere else, it just steams it out within its body and then tilts up and poops out the dry dirt until the tanks on the side are filled with the volatiles. Then it can go ahead and back up, connect. And we have this idea, I don't know if this is how practical this is, but you have the ice harvester and it transports to a stationary little station, such as on the floor of a permanently shadowed crater. and it produces very standardized ice balls, and using a small linear mass driver, it launches up to a net where it catches it. The ice ball falls down and is distilled and then transported and used accordingly. And what this does is this prevents the need of driving this icy regolith up the walls of craters. You throw it and catch it. So that's an idea that our organization proposes as well. So moving on to the next phase. So the previous phase was the StarHab phase. And while you have this initial permanent crew of perhaps 8 people writing the historic story of when humanity began to move off Earth. So this is your sort of Plymouth Rock sort of story that parents in the future tell their children. Even while these people are making history and demonstrating growth of plants and stuff, some ISRU using local resources, meanwhile, you have other cargo starships landing with habitats and equipment and stuff like this, getting prepared for the next phase, which I call the International Lunar Exploration Phase. So the ILEP. So we have on our website a page that describes all of the different categories of interesting places that international astronauts could visit. So why international astronauts? The reason for this is because, and it's sort of a first principles reasoning, it is who has the deepest pockets, governments or their richest citizens? Who has more money each year, the US government or Elon Musk? Well, it's the US government by far. And it's true for other countries as well. And so I believe that there will be a phase, the earliest phase, in which the per seat price for starships is going to be pretty high for several reasons. SpaceX needs to pay back their development cost. There's no competition, and they would like to make a profit to advance their goal for establishing settlement on Mars. And so I think the first price, the per seat prices initially is going to be quite high, and that seems ripe for governments to have an international lunar exploration phase and the establishment of an international lunar base. Now, there is a way that even if a seat cost $80 million, 2/3 of the countries in the world could be able to afford at least one seat. And if you increase the price to $87 million and you do some cost shifting, all countries could have a minimum of one seat. And so this creates an interesting sort of challenge where we probably need a coordinated international lunar exploration phase so that America doesn't go and visit all of the hot places, all of the Apollo places. They're the first one to go to a lunar lava tube and, hit all the things and leave. For other countries, they come in later and they don't have the same amazing experiences. Instead, there probably needs to be coordination through countries to allow each country to sort of have their day in the sun and to have their own Apollo moment, doing some remarkable sort of newsworthy sort of exploration. Plus also the two right-hand things. Not only could they be exploring the moon, but they could also be setting up habitats, including specialty habs, like Iraq with its history of the Hanging Gardens of Babylon. Would they like to develop one of the green habs? Plus also activities, races on the moon, doing dance in 1/6 gravity, doing these sort of spectacular sorts of things. In my opinion, bigger than the Apollo program, in that you'd have many, many countries participating in a positive collaborative sort of way of exploring the moon and establishing a permanent base. So at this phase, this exploration phase, let me go ahead and mention a couple of things, and that is roads on the moon. I think the easiest roads are compacted dirt roads with telerobots that sort of grade and rock rake, and then using an electric sort of steamroller compacting dirt roads. Why do we need dirt roads? Well, this picture sort of illustrates when you're on the moon without weathering, you have tire tracks that are left there forever. And so we can degrade the lunar environment appearance. I mean, there's no biology there, so we can't really harm the biology. But we don't want just tire tracks going everywhere. So we need to early on identify where we are going to put roads in the future. And there's a whole discussion about how we can do that sort of logically. And so in the Space Development Network, we have come up with sort of identifying where might people really want to go in a lunar grand tour. And then we sort of link together in a road network and then even going beyond that and saying what secondary roads might we want to have, and then have people stick to those roads so that we're just not defacing the environment, the surface of the moon. Also, in this international lunar exploration phase, there will be cargo landers that would deliver, in my opinion, the most logical form of habitats initially would be very large inflatable habitats. In fact, if you look at the 5 layers of inflatables, the 100-ton payload, if you use that notionally, would be able to deliver an inflatable habitat with about 2-acre footprint. So we're talking the potential of extremely large habitats, and then within that you can section it up into different sort of subhabs. And so I'm a big fan. I think that yes, 3D printing habitats are all the rage, but frankly, I think it's just you can use the strongest, best materials. You land on the moon instead of spending a lot of power and time to produce centered rocks, centered bricks or something. Instead, you just land in an inflatable habitat, open a valve of liquefied air, and instantly you've got a very large living space. So I'm a big fan of inflatables, and I think that's part of what's going to happen in the early phases of the International Lunar Base. So that's the third phase. So this is SpaceX concept for what they think an International Lunar Base could look like. I think it's going to turn out to look a little different from that, but I think this gives the general idea. And in my opinion, with the Starship fleet, the lunar base is going to develop very rapidly. It's going to be surprising how rapid it's going to develop, okay? And then we do, I believe, need to have spin habs, probably larger than this actually, because there is some evidence that the reduced forces that they will develop osteoporosis over time, and there's other concerns. The moon and Mars, I think we're going to need to have artificial gravity to extend crew stay for adults, and it's sort of urgent that we get what's called the artificial gravity prescription for healthy gestation before we have too many people going to Mars. Someone going to Mars or more likely on the surface of Mars are going to get pregnant, and then they're not coming back to Earth. If you're on the moon, you can come back to Earth in 3 days. If you're in low Earth orbit, you can come back in hours. But if you're on Mars, you're going through with the pregnancy. And so I think it's sort of urgent that we find out how much artificial gravity do you need to have healthy enough gestation in particular, and then after that, childhood.
On Mars.
On Mars, yes, it's difficult to get the radius long enough so you don't get dizzy when you turn your head. However, I've gone to my local theme park with the Gravitron and proven to myself that, it fits physics, and that is, if you don't move your head in any of the 3 axes, if you just don't move, you don't get the Coriolis effect. You're not changing, you're not accelerating your semicircular canals. And so you do sedentary activities, you do screen time just like we're doing now. I think it would be a full G for maybe 2 hours in the morning, 2 hours in the evening at max, and then the rest of the time they're out. The whole artificial gravity, there's a whole presentation on that, which we won't get into.
That sounds like it might be better to have something orbiting Mars or the moon that rotates.
Yes, in free space, you can get very large diameters. Of course, you need to deliver very large habitats and spin them up. But the problem is the radiation. So you're going to have to somehow off of the moon or off of Deimos, you've got to get a large amount of shielding to be able to do that. So I would say if we need to do these studies, if we can demonstrate that within a habitat on the moon, shielded habitat on the moon, if you're able, if you do activities that don't turn your head, if you're able to overcome the hydrostatic pressure distribution, there's the immune system and these sorts of things, not to mention the bone mineral density and the muscle mass, but intraocular pressure and intracranial pressure is a big issue. If by giving intermittent full G, we're able to get the harm down to what's acceptable, then we've solved the problem. And I think, especially when it comes to the artificial gravity prescription for healthy gestation, we need, in my opinion, we need to get the answer by about 2035, because I think 2035 is about the time that we'll have significant numbers of people going to Mars. And if one of them gets pregnant, that's an ethical nightmare. So we don't have a lot of time left. Okay, now phase 4 is private settlement. Remember, phase 3 is the international lunar base, and I think that it could grow very rapidly. There could be representation from a very large number. Basically, all of your Artemis Accord signers, they all could be represented in an international lunar base. But as the launch rate goes up and the per seat price goes down, you could have wealthy private individuals who pay the companies that the governments had developed surface systems like habitats, life support, growing food, sanitation. Private individuals now just pay them to do an incremental crank and produce another copy of their technology. That's proven to work. And so private individuals could be able to add on to the international base. And what happens is when you get a certain number of people, these people will tend to be older because you need to have lived long enough to save up enough money to afford not just to go, but to remain there and be, get all of your life support for the rest of your life. These older people, some of them will not be able to learn the common language. And so there'll be more Japanese businessmen, for example, and women who, when they reach a certain number of people, they will say, hey, why don't we pay these companies to develop a base or a settlement over yonder within driving distance of the international base. And then they have moving day in which they all sort of get in, they transport over, and they start inhabiting their Japanese language little colony. And then as Japanese come in the future, they will tend to not settle down at the international lunar base, but settle over in the Japanese colony. And the same thing could be true for Sunni and Shia and maybe Mormons and maybe libertarians want to have their opportunity. And so as I see it, there will be a transition to regional colonies that are still connected by trade and the peaks of eternal light. So they're in the South Polar area, but there could be locations where they do have access to ice, but also sort of peak areas of high power. And so if we do it correctly, I don't want to see fighting over borders. I'd like to see sort of like the Northwest Ordinance where, borders are drawn and then people settle, and they know that if you settle in this, your neighbors is what's going to eventually become your, in my opinion, politically independent colonies. And this is leading to countries. But let me just mention this technology at this point, and that is in the lunar highlands, 1% are unoxidized metal. And these are little micrometeorites that hit the regolith and create little crucibles and strip off the oxygens and leave these little globules of metals. And so if we can go ahead and beneficiate that, if we can separate out the metals, concentrate them, and then use like parabolic mirrors to concentrate sunlight, we can melt it, remove any remaining dross, and then need to process it to remove the silicone, the brittle silicone, for example, and be able to make metals without requiring a great deal of energy. Then we can start actually building structures out of metal. Metal on the moon is, of course, very handy. So as we have private individuals begin to spread beyond the international lunar base to their own sort of language-specific colonies, I think we can then begin to start looking at moving away from the poles with all of their resources and start heading south towards the equator. And this is where long-distance roads, I think, become very valuable, because when you have long-distance roads and self-driving cargo and crew vehicles, then all parts of the moon have the same access to the same resources of any other part of the moon, because you've created a transportation system. And suddenly you now have volatiles available at the equator, whereas right now there really isn't. And it takes about 3 days driving at 25 miles per hour to be able to deliver these things from pole to equator. So that's like a self-driving trains that just keep on a regular schedule delivering these resources. And so at that point, anybody can choose their part of the moon. In fact, I think that we should probably likewise begin to imagine what parts of the moon will in the future be designated as their own country. I don't think that there's going to be problems with establishing independent political entities on the moon or Mars, because I think when they grow to a large enough numbers, people on the moon or Mars are going to say, hey, why don't we govern ourselves? And frankly, there's not going to be any country on Earth that's going to say, no, we're going to send our Marines to stop you. It'll be a fait accompli. It will be, people will just go ahead and reach a certain point. I mean, with the Northwest Ordinance, I think it was 60,000 people. When they got to 60,000, I think they could vote their own governor, or they could apply to become a state. And I'm hoping for something similar to that. So that concludes my presentation about colonization of the moon. I appreciate your attention. Let me just say that I did look at your guys' website, Ecomodernist. I saw your manifesto, and frankly, I'm rather excited. I think that you describe a very practical way of helping the environment by using technology. And frankly, I think it's sort of genius in that I think that your philosophy is something that even conservatives who are not typically your environmentalists could nonetheless say, hey, if we don't have to harm the economy, but we can use the technology to improve the environment, I'm not against the environment. I think you guys are really onto something. And so I wish you great success.
Gabe, did you have a question?
I've heard that it's almost maybe a showstopper, the moon dust, which gets in machinery and everything and just eats things up. How does that play into this?
Yeah, so maybe Einstein, if this is a quote from him, he says, clever people find solutions to problems. Wise people avoid the problem to begin with. Okay, so first of all, let's not be tromping around in our spacesuits in the abrasive regolith, the lunar dirt. You can use coveralls. There's these metal suits and things like that can help with that. Now, if you're making roads, that is an issue. But Greg Biden, he's like one of the leading robotic mining people up in Canada. And when he was on the space show, he said that the mining industry deals with abrasive dirt, dust all the time. There are certain environments in which they do that. He says they've solved those problems. He personally didn't think it was going to be much of a problem to have the right seals and the gears distant from where the dust was being produced and stuff like that.
Mm.
Great. Well, I've got a question. What kind of investments would you like to see bootstrap in order to support this kind of a mission? Is there like literally more money into rockets, or are there other enterprises that develop in parallel?
I personally think the rocket transportation is being taken care of thanks largely to SpaceX, albeit Blue Origin with its hydrogen and oxygen might actually be a very interesting lunar ferry, refueled by ice on the moon. But in my opinion, I don't want the government to be spending more money on rockets. I really think that the focus, they need to accept that the future is the Starship fleet, and they need to get ready to take full advantage of that capability. Right now, they're not. And to me, from a policy standpoint, that'd be the single biggest policy change I'd like to see them make, and that is to start planning on using that capability, because it's going to be here pretty quick. So how do you take advantage of it? I really think that we do need to have a specific plan for the surface systems. I mean, I've described sort of step by step about how I think it's going to play itself out. And we need to be funding companies to develop very large inflatable habitats, to have power systems that get into the megawatts. We need to have really solve the ice harvesting problems without these perpetually small demonstration CLIPS landers. We need to accept the LCROSS results from 2009 and say 1 part per 18. It's within driving distance of peak of eternal light D. And we need to be willing to move forward and actually start developing these systems, because we have a real deadline that's being pushed by the Starship fleet.
So You went over a lot of the phased development, and you said it would be about a decade in order to really make some moves towards making this happen. Is that really the total time investment, or is this waiting for technology to develop, promoting the idea, building up the infrastructure on Earth needed, and then launching all at once, or is it more incremental? What's the exact development timeline that you're thinking?
Fair enough. Okay, so a lot of caveats here. We all know nothing happens unless there's funding.
Mm-hmm.
Okay, and honestly, some of this funding could get down to a single billionaire funding. So Bigelow is not really in business anymore, but they developed inflatable habitats, and they didn't need $1 billion to do it. I mean, he was a centimillionaire, and he was able to make some progress there. So what I would say is, I think if there was a decision now and there was funding for the Star Hab, I think that could be landed on the moon in less than 10 years. I mean, if you look at the Starship fleet is going to be in the hundreds by 2030. And so I think 2029, somewhere around there, we could have the Star Hab if we chose to do it. Okay. In terms of the phase after that, the International Lunar Base, I would say that it's not like new stuff. We just need to have a program that says, we have a deadline, let's develop it at scale, meaning, large habitats, not small demonstration habitats, for example, large life support, not just a small demonstration. I think as soon as we can free up the money, I'm not asking for a bigger budget for NASA. I am saying let's use our money better. And personally, I think the budget that we have right now, if used more effectively, I think would be more than enough to develop the technologies needed to establish these bases.
Great.
Chris?
Yeah.
Yeah, I guess again, kind of a two-part question. Resources on the moon. Let's say over the course of a decade, we have 3,000 people that go to the moon, fill your multiple habitats. How long would those resources, especially say the ice and methane, water on the poles, how long would that last before they start to run dry and they become dependent on possibly Earth sending them resources monthly? And also, what about resources on Mars? How does that figure in for long-term civilization?
Okay, so the best estimates for the ices on the moon are a minimum of 600 million cubic or metric tons. Okay, if you recycle, which I think we definitely should recycle on both the moon and Mars, you can have about a kilogram of food and volatiles that you consume per day that you lose in the recycling process. So just to answer your question, I've done the calculations. A city on the moon of 1 million people that recycles at 1 kilogram that they lose per day, it would take them about 1,600 years before they would consume all of the volatiles on the moon. Within the 1,600 years, undoubtedly, we will have developed the ability to import asteroid and cometary materials and drop them on the moon. In other words, they will never run out of these things on the moon. So I just don't think it's a problem if we recycle.
Okay. And how about Mars? They
Mars.
also have enough to start with?
Whew. Oh, yeah.
Oh.
I mean, Mars has oceans worth of water, literally. I think if you were to melt all the water and it would go to sort of the northern hemisphere, I think it'd be about a kilometer thick, something like that, or a mile thick, something like that. So like no shortage. If you were to take the entire atmosphere of Mars and condense it down to about like 90 feet, I think it was, you could get the pressure to about a half atmosphere, which we can live in. Okay. And so if you had inflatable greenhouses that you had tethers and you basically pump the air in until it got up to high enough pressure, and you could convert that CO2 and O2, and you could even selectively get the nitrogen out, so you could actually have Earth-like atmosphere within these very large greenhouse areas. You could fit, I think, by my calculations, about 9 billion people within a paraterraformed area. with Earth-like atmosphere. Now, there would be certain of these things that would be just CO2 without the nitrogen, et cetera, but there's no shortage. And in fact, I think plastics on Mars need to be an early priority, because the moment you can produce plastics, now you can produce countertops, tables, chairs, desks, sinks, stuff like this. And so you don't have to ship those things anymore. Mars is both very large quantities of resources, plus also very accessible. On the moon, there's sufficient quantity, but the accessibility is significantly more difficult because you have to go into cryogenic areas. But in both places, you have enough.
Okay. And your idea for people, large numbers of people living together in a habitation would be a personal space similar to New York City or Hong Kong, something like that, roughly?
I use Austin. Austin is 1 million people, and there's a certain density of population there now. They don't have farms within the cities, but you optimize the greenhouses and you control everything optimally. The irrigation, the fertilizer, the humidity, the lighting, everything optimum for maximum production, including increased CO2 levels. And you can significantly reduce the amount of space needed to grow the food for the people. So I just use Austin as my standard.
Austin, Texas, not Minnesota.
Oh, I didn't know there was an Austin, Minnesota. Yes, Austin, Texas.
Yeah, there is. Okay.
Wonderful. I think that's been a really good amount of content. We got most of our questions answered, unless you've got one.
Yeah. Yeah, I do. Okay. Actually, we could go on for forever with this. So interesting.
I know.
Okay, you say you could you plan to like have these blow up houses, but I see two problems. One is you have tremendous radiation, and the next one is you got tremendous heat, which could degrade the whole structure. I mean, isn't this a problem? Major problem?
Yes, but they're in my opinion, fairly easily solved. Now, by heat, are you talking about external heat like sunlight or internal heat of
both really? I mean, the heat's tremendous during the day, you know.
Yeah, so first of all, we start at the poles, which has not such extreme temperatures. And the key thing is that you cover the habitats with sufficient regolith to protect it against radiation. And exactly how much do you need for long-term, keep your 2% radiation-induced exposure death down to 2% or less? I don't know what that number is, but it's somewhere around 2 meters thick, something like that. So there's two ways that you can do it. You can design your habitats to where they're sort of like for if during the inflatable phase, just like air mattresses have internal tethers or internal dividers. Likewise, in your inflatable habitats, you can have a flat roof that's sort of bumpy but roughly flat, and you can just toss the regolith on top to whatever depth that you need. And that's going to protect you against radiation. It's going to easily protect against micrometeorites, and it also provides insulation so that you have really moderate temperatures. Now, probably, and you don't have direct sun. The sun is on the regolith, not on your habitat. But probably with that amount of insulation, you're going to be building up heat inside, and so you do need a way to reject the heat. And I think that's just through tubing that goes out to radiators, and you have a fluid that conducts the heat on out and is radiated through infrared radiation.
Yeah. I got one more question. How about the Chinese space program? I mean, where does this? Yeah.
Question, does the Chinese space program, how far are they along on their equivalent to a Starship fleet? I don't know if they've even started, but anyhow, they're not close. So frankly, this is, again, I emphasize the Starship fleet. This is what's going to change history. And might China send some taikonauts? Might they sort of have a secret behind the scenes program? They're going to try to beat us to the moon, back to the moon. I would say maybe yes, but that's not where history is made. That's not the big historical prize. The big historical prize is when does humanity establish, when does settlement start? When do we establish our first permanent foothold that grows to scale? And honestly, I just don't see how the Chinese can compete with the Starship fleet. And we're going to be ahead. And honestly, if you take a look at the number of countries that have joined the Artemis Accord versus the Russian-Chinese International Lunar Research Base, it's like we've got far more, and they're far more democratic, and they have far fewer, and about, I don't know, 60, 70% of them are dictators. And so if you are a free person, if it's your money that you're going to spend to settle down, which colony are you going to go to? Very few people are going to go to the dictator's colony. So I honestly, I'm just not too concerned about China. I think they're just too far behind. They're not attractive. I think the future is the Starship fleet and the countries that are going to help start settlement.
Wonderful.
Okay.
So this has been the Ecomodernist program, and I want to thank our special guest, Doug Plata of the Space Development Network, for being here and giving us so much great insight. So this has been the Ecomodernist channel live. We broadcast 10 a.m. Pacific, 1 p.m. Eastern, right here on YouTube on the Ecomodernist channel and at Patreon at the Ecomodernist channel. So please support our mission, and remember, missions first, peace and justice will follow.
Please subscribe to us on YouTube, Ecomodernist channel. Also to subscribe to us on Twitter and Facebook, Ecomodernist Society of North America.
And online at https://esna.earth.